Let me do that. Okay, cool. Madhurima, all yours.
Thank you, Prachi. And yeah, as Prachi mentioned, most of these techniques are backend engineering, and data engineering, data science, or machine learning is also a part of backend, the broader backend engineering. And so we decided to just give you start with an overview of data engineering, and then machine learning and data science, and then dig deep into what a day-to-day data engineer would do with some generic examples. So data engineers, basically what they do is they design and build pipelines. And this is mostly to get the data from multiple sources or databases and transform it so that it is readily available by basically other users. And that can be data scientists, that can be end users, that can be front end users, that could be any customers, it could be anybody. But there are steps to it, but their main role day to day is to build these pipelines so that all the data coming from different systems, different formats are consolidated at one place. And now for the steps, it could be collected in one single data warehouse, it could be collected in a database, but the whole idea is to uniformly collect everything and unify it so that it can be readily used. And these data engineers, they work very, very closely with DevOps team members and data science or machine learning teams. So it's a very collaborative role, and you always need to work on teams. Why is this? Come on, why is this not? Okay, here it is. So as I mentioned, data engineers basically develops and builds pipeline, and their role is to maintain this and make it more reproducible, usable. And it could be on-premise, it could be a combination of on-premise and cloud, it could be everything on cloud, it could be multi-cloud. And the rules are so generic, and that you can kind of deploy it anywhere you want, depending on the requirement. Now, what a data scientist does is a little bit different from here. A data scientist takes all this data that has been unified right now and tries to gain more insights and find patterns and do some forecasting to gain to understand what the data is saying. Like most of us data scientists, what we do is we build mathematical and statistical model, and that is what is generically known as machine learning models. But underneath everything, it's just what can we learn from the data? How do we analyze this data? What kind of mathematical models needs to be implemented to make sense of whatever I'm seeing? So that is the major part of what a data scientist does. And a machine learning engineer, it works very, very closely with data scientists. What a machine learning engineer will do is design this architecture or pipeline to integrate and automate whatever a data scientist has done, so that that part can be a part of this entire system. So let's say, and I will show with an example what I mean, but the major task of a machine learning engineer is to build the pipeline or the software to automate the running of the process, so that a person like me doesn't have to be present every time there has to be a forecast done, or there has to be some new pattern which is found out. So that is the task of the machine learning engineer. Okay, so this is where I can explain, it will be very useful And I'll tell you which parts of this whole diagram is done by a data scientist or a data engineer or a machine learning engineer. So I'll start with the user interface because that is what the end user is seeing. So on the right-hand side, let's say you're seeing a dashboard, or you are seeing a website or a phone app, or even a presentation. So all of these are the result output of whatever has happened before that. And let's say I'm going to take a website, right? A website will tell you, like, let's say a weather forecast. You want to see a weather forecast and you go to an app or a website. Where is that data all coming from? So all these data sources, let's say there are some Oracle databases or MySQL databases or some data warehouses. There could be some Excel files, there could be some API calls. So all of these are considered as the input data sources. And then after this data is ingested into and cleaned and processed and transformed, and it could be done in many different ways. That's the final output of that transformation, analysis, and processing is what the end user sees on the front end. And all of these parts happen, like there are different roles which take care of different processes here. For example, if I'm a data engineer, my major task is to identify all of these sources and ingest everything into a common format, either into one data warehouse or one data base, or a cloud data warehouse or a cloud system on cloud platforms like Azure or Google or AWS. That is my task as a data engineer, is to collect all of these information in all these different formats, but make it into a single format, and so that it's readily available to do either analytics or visualization, or it is used by a data scientist or anybody. So that is the task of data engineer. For a data scientist, the data scientist sees the data that a data engineer has already collected. So now, as a data scientist, I don't have to go and look at all these multiple sources and start doing cleaning. My task would be, now that I have the data in one place, in one format, what kind of cleaning I need to do, what kind of processing I need to do. Can I do some enrichment on the data? What kind of insights can I get? Can I apply some machine learning model? And then kind of put that result into a visualization form or some kind of more layman terms or business terms, because I want to imply what I have learned from the data. So I would need to build, let's say, some kind of a dashboard or just a simple website or even a PowerPoint to say what I have learned from the data that I have been provided. So that is, in a broad sense, what a data scientist does every day. And for a machine learning engineer, as you can see, they focus mostly on the middle portion of this data architecture diagram, but the task is to automate this entire process and integrate it with the larger scope of things, so that a data scientist doesn't need to sit there every hour or every day to run this process, but they can just keep track of what needs to be changed, how it needs to be improved, and so on and so forth. But it can happen automatically, and it can be integrated very well with the overall picture. So that's the main task of an ML engineer. So I will pause here a little bit, and I'll just ask everyone if they have any questions on this, and like, what do you think, or what did you understand as who are data engineers, data scientists, machine learning engineers, as an overview. You can unmute yourself, and or you can use the chat to answer, or if you have any questions on this before I move forward.
We have a question from Rachel. Thanks, Rachel, for asking the question. How often do these roles overlap in practice?
They overlap a lot, and I'll talk about the overlap in the coming slide.
Great question.
Yeah.
We have another question. Yeah, we have another question from Lisa. I may have missed, but what did the EDW stand for?
Oh, yes, EDW is Enterprise Data Warehouse. So think about a huge company, right? They won't have just data in a hard drive or just one database. So data warehouse is just a collection of a lot of databases, and that's so that you can have huge amounts of data. And it could be that.
Yeah. Got it.
Thank you, Lisa. We have another question by Lydia, if I pronounce your name correctly. What qualifications do you need to become a data scientist?
Definitely very strong statistics and mathematical model background, and strong coding. It could be either R or Python, but definitely need to know statistics and coding to start with.
For sure. Another question by Rupali. What tools, softwares are used frequently for data engineer, data scientists, and machine learning engineer?
Yeah, I'll cover the tech stack for data engineer today, and I'll give a brief overview of data scientist and machine learning engineer as well, but most of them are very similar to each other. So I would say one language, choose your language, R or Python, Java, Scala, anything you want. And then some kind of cloud knowledge is helpful for data engineers and machine learning engineers. But I'll go deep into this. Yeah.
Yes, and even we have the second session in a couple of weeks where you will also look into data scientists and machine learning.
Yes.
And the technical side of things. Yes. Another question from Yana, if I pronounce your name correctly. What are the qualifications for machine learning engineer? We have a few more questions. Do you want to take them now, Madhurima, or later on?
Yeah, let's park the questions for a little bit later.
Yeah.
Maybe I'll cover some of them in the coming slides.
Right.
But if I don't, then yeah, I'll try to answer as much as I can. But again, just as Prachi said, we'll cover in detail data science and machine learning engineer in the next session as well.
Right.
So it's
right. Keep your
get back to you.
In the chat, but we have a long way to go. So let's
yeah.
Thank you all. These are great questions.
So again, just to summarize, data engineer develops data ingestion pipeline, takes data from multiple sources, multiple formats, combine them into a single source. Data scientist tries to find patterns and meaning to the data by either doing statistics or building machine learning model. And machine learning engineer develops scripts to integrate the work of data scientist with the larger picture and automate the work that a data scientist is doing such that models can be triggered and run without the presence of data scientists all the time. So coming back to the question, I think Rachel asked, how do these roles differ or are similar to each other? What do you guys think before I jump into the question. Does anyone have any thoughts on that?
Feel free to speak from your experience, for sure.
There is no wrong answer.
That's true.
So I'm assuming data scientists come up with the actual mathematical models in terms of what will actually fit the data, what kind of curve will fit the data or something like that. The data engineers actually build those pipelines, like you said, that can be triggered so that the data scientists don't have to be involved every single time this to be run. So building pipelines, maintaining them, integrating them with DevOps, etc.
Yep.
And machine learning engineers, in my opinion, probably are involved with coming up with, first of all, what kind of whether like, you know, whether it is regression or what kind of, first of all, model lacking a better word, first of all, asking the right kind of questions, what needs to be worked on, what kind of algorithm to choose. I could be wrong, but something in that direction.
Yeah, as I said, there's no wrong answer, but you were pretty much correct. The only difference is, yeah. So machine learning engineers, I'll start with that. They take the models that the data scientists have already developed. So the questions that what kind of model is required, or what kind of statistical test is required, what kind of analysis is I need to do. Those are the questions which a data scientist would be asking, and they would be developing and building that model as well. A machine learning engineer sits down with the data scientist. I work very closely every day with a machine learning engineer, and we discuss that, okay, let's say you're getting very good results from two models, right? Which one do you use? You can't use both. So which one to use? Which one will integrate well with the overall pipeline? Which one is easier to automate? Or which one makes sense for the huge data that is present? So all of these questions and will be kind of, it's kind of a, as I said, like if you look at this diagram, kind of you test and figure out which is the model that is the best, that can be deployed in production and can be run readily. And that is what a machine learning engineer will do, and help a data scientist to kind of figure out. It's not only always about, oh, when can I get 99.9% accuracy, but maybe you are getting 85% accuracy, but it's doing very well in production and it's very well integrated with everything. And you don't have to, spend 7 days to come up with the result for that. So those are the things that a machine learning engineer will kind of help guide a data scientist to figure out. So they work very closely to figure out which machine learning model to use, and then finally deploy it in the automated pipeline. The difference is that they are very good with automating and writing scripts for automating that, and they will focus more on that part. A data scientist will kind of do the experiments, if I call it that, like building the models, analyzing the data more locally rather than just doing it in the entire infrastructure. A data engineer does a little bit different work. They take the data and make it available so that it can be queried by, let's say, a machine learning engineer or a data scientist. The common things between a data engineer and a data scientist is both of them need to do a data quality analysis. Both of them need to do a data cleaning, data pre-processing, let's say, get rid of null values or put everything from string to date format because you need the date. So they both have to do some kind of SQL queries to figure out how the data looks in the database or how the data looks in, I don't know, Excel. So all those kind of things are very common between a data engineer and a data scientist. Data engineer and machine learning engineer also works closely because they need to, a machine learning engineer needs to develop the pipeline that this machine learning engineer has developed needs to be tied up with the pipeline that a data engineer is developing. So it can't be just two separate things. You need to bring everything together. And I mentioned CI/CD here. It's continuous integration and deployment. This is something that all three of them needs to know. It's kind of a process where you are continuously integrating your work as well as you're developing new things. So you don't want anything to break. So there is a process where you you develop it and then you test it and then you deploy it. And then again, you develop a new thing, then you test it, then you deploy it. So it needs to be done on a very systematic and a continuous process. And it's very, very important for a data engineer and a machine learning engineer, but it's also important for a data scientist to know that. And hopefully it's clear what are the differences and similarities between those two. There's a note that I wanted to make before moving forward is all these three engineers, they make use of some pre-existing or pre-built models or libraries or functions. It's a little bit different from a software engineer or a software developer, where a software developer or engineer writes a completely new thing from scratch, their own function. It's not that. So you will see a lot of the times, all these three roles, they are like importing or making use of Python libraries or R libraries. And it's okay to do that because their role is slightly different from a software engineer. They can make use of the, let's say, functions or the libraries that are already there. We do write our own, don't get me wrong, we do write our own functions and custom code wherever it is required, and it is required a lot. But make use of things like anybody who has heard a little bit about machine learning or data science has heard pandas or PySpark or Spark. So these are all like modules which are readily available for us to use, and we definitely make use of them because those are written very well and it increases the speed and performance. So I just wanted to let you know that in one example, I'll show you how we read these things. So just wanted to let this known to everyone beforehand. Any questions before I move on to a day in what a data engineer does?
Sorry, yeah, go on.
Sure, go ahead.
So from the looks of it, the data engineer is more concerned with the data itself, like cleaning it, pre-processing it. So it seems like they don't have any statistical or they don't necessarily need to have any statistical or modeling related knowledge. Like a good SQL background should be good to start, at least. Is that a fair assumption?
Yes. You don't need to be expert in statistics to do data engineer. That's for sure. SQL is definitely needed, and I will go over like some you're going to handle a lot of big data. So all the big data technologies like Spark or Hadoop or Kafka, that knowledge is definitely needed, because you won't be handling like 1 gigabyte or 50 gigabytes of data. You'll be handling like much more data than that.
Gotcha.
We have one question in the chat, like how prevalent is the use of R right now, other than at Google?
Oh, R is used very often. might not have heard, but a lot of, I can tell from my experience, a lot of healthcare companies use R a lot. A lot of, actually, whenever I have to do more statistical tests, I prefer R because their functions and inbuilt libraries are very, perform very efficient. And I know I have worked on, and I know from my experience earlier that a lot of biology related work is also done in R. So it depends from, like, it's again very company or industry focused, I would say, or even like academia focused. Like it depends on what kind of problem you're trying to solve. Sometimes maybe R is easier, or building a dashboard in our Shiny is easier. So we'll just do it in our R. So it's not like it's not at all used. It is used. It's just depends on which company or industry you're going for.
I think we can move forward.
Okay, so let's move forward. So the day-to-day task of a data engineer, again, this is reiterating, but making available at one place all the data sets from variety of sources and variety of formats, building the pipeline. These pipelines, what they do is they should be able to, depending on the problem, they should be able to do either stream data or batch data, and I'll go over what they mean. These pipeline perform some kind of extraction, transformation, or loading of the data. So this is in short called ETL. And then some basic conversions of formats, governing the data, indexing the data, and so on and so forth. And I'll go through each of the steps in detail. So, okay, so this is what I mean. So let's say I am working at some company where I have some internal data present, and some of it is present in Oracle database, some of it is in Postgres, and some of it is in, let's say, cloud, like Snowflake, cloud data warehouse. I want to kind of take all of these and consolidate it in one place. I also want to gather some external data, which is, let's say, present as an API or in JSON format or XML format, and add it to my existing internal data. I also have some manual source files. Let's say I have a team who has data only in Excel format, and I want to consolidate all of these into one place so that I can find out what my customers want. Let's just say that. So just to give an example, like text file generally looks, this is an example of text file. Like let's say there's an ID, there's a name, and I have age of all of these persons. And there's a CSV file, it's just comma separated, but difference in formatting. An XML file, let's say I gathered it from external source where I say, okay, this is the message sent by this person, and I want to collect all the messages to kind of figure out something about the customer. And I get a JSON file from their Twitter account, let's say, as an example. And so a JSON file for a tweet looks like this. And then I have my internal, some information stored in Oracle or MySQL. So this could be a variety of data formats that I need to align together as a data engineer and collect it from all these different sources. So now, question for you all. Which one of these do you think is a structured versus unstructured versus the semi-structured data format?
Yeah, the .txt and CSV are unstructured, and
Correct.
XML and JSON are structured.
Anybody else before I give the answer? Any other guesses? Oh, Parquet is another format, which I forgot to mention that. Thank you. For Parquet is another format where you can break it down. It's think of like a huge table, but it doesn't appear as a table. It just appears as a partition version of it. So it's another kind of format that is very useful for data loads and data ingestions. So you're right, text and CSV are they are unstructured data. XML and JSON are semi-structured because and anything in a database or Parquet is structured. So when I say structured, think of it as a very nice database table format. So these three are the most structured version of data. And XML and JSON, as you can see, it's not really a table format, but it's not as unstructured as text and CSV as well. So it's in between. So that's why they are semi-structured. And okay, so the next question is, which data format do you think is more user-friendly versus which one is more storage efficient or performance-friendly? And these are the questions which a data engineer has to kind of like know offhand, because that's how you'll be able to you need to convert and finally put it in one unified structure. So that's the reason that I'm asking this question. Any thoughts? Yes, I think most of you have gotten it correct. Text and CSV are more flexible for users because you're more used to it. CSV, Excel, so you can just go edit it on the fly, but it's not as efficient storage-wise or performance-wise. However, Oracle databases or Parquet format are very, very extremely efficient in storage and performance-wise. So XML, JSON, somewhere in between. And it's not so easy to, if you're aware of the structure and you know XML and JSON offhand, it's easy to edit. Otherwise, it's not as easy, I would say, as just writing a text file. So that's the difference. So this on the left side is more flexible for users, more user-friendly, versus databases are more efficient storage and performance-wise. So just to summarize, I can have multiple sources, internal and external. I can have structured, semi-structured, or unstructured data. And what I need to do is I need to combine all of them and make it available in a same place. That's where the first job, that's how I have to design my pipeline so that it can do all of these things. Now, before I design for the right code, I need to figure out whether I'm building the pipeline for ingesting streaming data or batch data or both. Now, streaming data is what I would collect in real time. So think of it like real time. Think of examples like you're doing, log files that I'm generating while I'm using a mobile app or a website, or the purchases that I'm making. It just goes through, in a second or a couple of seconds. So these are data that is being handled in almost real time. Or if you are experts on video games, then all the player activity that has to happen in real time. So all of these are streaming data. And before I design a pipeline, I need to figure out, am I ingesting a streaming data or am I ingesting batch? So I'll go with an example of how to ingest or how to read streaming data. And this is how you would do it in Spark. And remember, I was saying that we make use of pre-built functions. So at the top, before I write anything, I need to call these functions first. The one I have highlighted in the box, in the box. So I would just start a Spark environment, let's call it, and I'll start a Spark session. And this would be, the Spark session will have this kind of syntax where master would be my compute node, like where I want to do this process. It could be a Spark cluster, which is the distributed environment, or it could be my local machine. And then the app name here is the name of your application that you want to get data from. And then I want to set what is the interval that I want to gain data. Like, do I want it at 1 second? Do I want it 60 seconds, a minute? So this is kind of a generic example of how I would get get streaming data in Spark. Batch data, on the other hand, is not real time. So most of what I would call a batch data, or not most of what is batch data is when you're moving or when you have huge amounts of data. Like, think of data stored in a database, and I want to move from a database to, let's say, cloud. I want to move this entire thing. So that would be a batch process or a batch data ingestion. And so there are two ways to read a batch file. Well, you have to read and write. So again, going to Spark, you can do spark.read.format, and you can specify what format you need. So that's where we need to know what format files I'm using. Do I have a CSV file or a text file? And these are different options that you can kind of add. Fail fast is, if there is a failure, just let me know. Infer schema is, do I replicate whatever is present in the CSV format that I'm reading, or do I use my own? Do I define my own? So if it is true, then it will copy exactly how it is present in that document or in the text file that I'm reading. Then you can specify the path to the file. You can say what kind of schema you want, and then you load it. And now that you have read all of this, you need to basically write it somewhere. And I think I read somewhere in the chat that the end goal is to put it in a structured format, and that is the correct one. So the easiest way to do it is to write it in Parquet format. And again, the syntax is very simple. You just write it in kind of a data frame process in Parquet. Parquet is easy to handle, And you can specify, do I want to overwrite, what kind of format I want, then save it, basically. And yes, so different save modes that I have is, I have the option, do I want to append it to the existing file at the same location, or do I want to completely overwrite with the new data? Or if I want to say that, okay, don't write it if it already exists. Or I can also say, okay, if it already exists, do nothing. It's just a check. I'm checking if it already exists. So there are different options as to how I would want to write this data. And I say Spark because Spark is a distributed system and it helps to handle or read huge amounts of data very, very quickly. So that's why Spark is the base for most, I would say most data engineer jobs that I have seen in my experience. Again, if anyone has heard of Databricks, not necessary, but I just wanted to throw an example out here in case anyone is interested. But you can also do the same building of data pipelines and ingesting, streaming, and or batch processes in Databricks. And this is how a generic code would read. So let's say I want to read my data from AWS location, S3 storage location. So this is, I would just say spark.readStream for streaming data. And for batch, as you can see, I just say spark.readJSON. So it's the same format as I discussed before, where I said spark.read format. So now I know it's JSON format. So I just say spark.read.json. This is for batch process. If you look at the write statements, these are just, I'm specifying the time. Let's say I want it at an hour. I want to write it in MySQL. So here's my address to MySQL, and I say write stream.format for streaming data. For batch data, I just say write.format, the same function that I was discussing just in the previous slide. I know this is a lot, but and this might seem like a lot of codes, but if you're interested, I have links to at the end of the slide. You can go take a look at it and read up more on how to do it on Databricks or even Spark. So just simple things like what we learned. What are the examples of streaming and batch data? And yes, Tara JSON is user-friendly, but it's not as efficient as a database. So that is why you would want to put everything in a database. And just because JSON is still like single files, but in database, you can put multiple JSON files in there or in a data warehouse. So that's why it's very, very performance efficient and storage efficient. Sales data for a month might be batch. Yes, correct. Yes, data from IoT services are streaming. Perfect. Network monitoring is streaming. Yeah, you pretty much got it. Social media data might be streaming. Yep. Yep. All of these correct answers. Credit card for streaming. Yeah. So e-commerce, financial, social media data, trading data, all of these are, oops, what happened? All of these are streaming data. Oops. There is a typo, sorry. This is examples of batch data, the one below, or from databases or enterprise data warehouse. Those are all batch data. Sorry, this should be batch.
Basically, anything that is live or dynamic,
Is streaming. Yes, correct.
and something that is persistent, but a bigger chunk of data as well would be considered batch data or batch data processing, right?
Yes, yes, exactly. Thank you for the summarization, Prachi.
My understanding. So yeah. Okay.
Okay, so now to the most fun part is now I'm building the pipeline to do this whole extracting, transforming, and loading it to the final output. So let's say I have multiple databases. I would do some transformation depending on what the purpose is or what the ask is. And I want to define a common format so that I can put all of these data together. And then finally, I would want to put it into a data warehouse or a data lake. So question before I start, let's say now you know what a streaming and batch data is, how now you want to extract the data from multiple databases and put it, let's say, on a cloud. How would you go about, like, what are the steps do you think that I need to think of to do this whole extraction process and loading process? Like before even I write a code, like what is the design, like what is the planning that I need to do? Ideas?
Data conversion, like converting it to the format that cloud storage accepts.
Okay, so cloud storage is nothing big. It's just think of it as your Oracle. Think of it as an Oracle database, but on cloud and not on some hardware sitting next to your office. But yeah, we need to think of the format, yes. But even I'm telling even before that. Understand what is the source? Yes. Need to understand what is the source. Sorry, how will the source send the data? Schema, yes. Connect to databases, yes. Okay, so let me tell you. So the first thing that as a data engineer, I need to think is how to handle what we call as the day zero load, which is everything that currently exists. And the second step would be how to handle new incremental data after I have moved it to wherever I want to move it, or after I have consolidated everything. So that is the first step. Is because let's say today I decide that, okay, I want to take everything that is present, let's say on my computer, right? I have like bunch of Excel files and bunch of JSON files. And today I want to migrate everything to a database. And then I want to keep on doing this after today. But how do I handle everything that I have collected for the last 5 years? So that is where is the first partition kind of that happens for a data engineer, because once you have set up the whole system, you can kind of figure out how to do the newer version, because new data is going to be much smaller than last 5 years, 10 years of data. Even like think of it, even on our computer, if today I wish to take backup of everything that I have on cloud, let's say, or on external hard drive, I would have to move a lot more data versus if I want to move something tomorrow. So it would be just tomorrow's increment, or a week's increment, versus let's say I have this computer for, I don't know, 5 years. So that's the first thing that I need to figure out. Does that make sense? So once I have done that, so now for day 0, that is the already existing data load, what I need to do is I need to partition the data. I cannot move, say, let's say 100 terabyte of data, same as how I would move 1 gigabyte of data, right? So I need to partition that data. I need to keep track of this partition so that, let's say I am loading first one every years of data. So I need to keep track, okay, when did the data stop at 2010? Am I keeping track of that next 2020? So something like that, keep track of the partitions and then load all this partition data so that I have everything migrated to this new system. And then, and then once I have everything decided and everything loaded from day 0, now my incremental load is much smaller. So I can decide the frequency. Do I want to refresh and include new data daily or monthly or yearly, depending on what your purpose is, and then refresh the table with the new data so that the new data is appended. Yeah, so these are the basic first few steps that I need to think of before I even start writing any kind of code. Yeah, so this is an example of how I would write the code on, let's say, Databricks. And if I want to move it from a database to Azure Data Store. Again, I say Azure because this is an example I took for Azure, but most cloud platforms have a similar structure. There might be few, formatting changes based on what cloud you have. It's very easy to look those things up, but the main idea is I want to write this code only once so that it is reusable, and I don't have to define, okay, this is my table name A and B. I want to make it as generic and as parameterized as possible so that this can be reused and repeated. And I just need to do some governance or like maintenance to see, okay, is my pipeline running correctly? But I don't want to rewrite these codes again and again. So this is again an example of how I would write the code. So I'll define a table ID, and this is kind of a pre-built function that I would use to get the table ID. And again, as you can see, I'm not really saying any table ID. I'm just calling it as, I'm just calling a table ID, which is present. And since I will be dividing it into partitions, so each of these let's say runs, or each of these partitions, it's called running a job. So every job will have a job ID. So it's same as you're running an experiment or you're running the code. So every run will have an ID, right? So that's what is called a job ID here. So I'm going to get the job ID because I need to keep track. Remember, I need to keep track of how many partitions I'm making and where I'm making it. So that job ID will tell me that. And then here I am kind of loading the configuration to the cloud storage. These structure will change depending on where your storage is. I'm defining the path to the cloud storage. And then I just set the destination table name, destination table folder where I want it, set the source table path and make it, again, as you can see, parameterized, and also the destination path also parameterized. So that is what, oh, did I just make a typo here as well? Yeah, this should be table name, sorry. So set my source table path, set my target table path. You can see there is no names. I want to make it very generic. I want to make it parameterized so that whenever there is a new table with a new job ID that will come in, it will automatically run. As you can see, by ID, it will automatically run this. And that is all I have to set up. Any questions before I go into the actual code of what to do? I know this is a little bit code heavy, but again, if you write this codes and run it anywhere, this will not give you any result. But you need to define the path and you need to set the parameters before you put these table names and source path and source things. And you need to also define from where you will be reading. So this is just to give you an example of how you can make it more reusable. And the storage configuration path that will change depending on whether it's Azure storage or Oracle storage or enterprise storage. So just have to figure out where I am going to put my final destination. Okay. So this is where you're writing, I'm writing actual code. So once I have defined everything, again, I import a few Python and Spark functions. And these are the ways to import it. You just write from import this or from PySpark. Okay, PySpark is when you're combining Spark and Python together. So Spark is compatible with Python and Scala. So if you're used to Scala, you don't need to write it in Python. You can write in Scala as well. And sometimes Scala does much better, faster, works much faster than Python and Spark. So if you're used to Scala, then this formatting will change again. So once I have called these functions, now remember we discussed how to read data. So spark.read.format. I'm reading batch files in Parquet format and loading from the source path. And this is where I'm kind of defining what kind of transformation I want. Let's say here, I want to filter out with these files with job ID. So that's what I'm defining here. So that's how I'm keeping track of the different partition files. And then finally, I'm writing it as an output. And create table if not exists. This is a very SQL command, right? So I want to run the SQL command. As you can see, I'm saying run the SQL command, and I'm saying create the table only if it doesn't exist, and use that table name which we defined, and use the location which we defined before. And then I'm saying Spark run the SQL command in distributed way. And what you would do is, before that, I have already saved these as a format that I want. Let's say I want it in Parquet. It's a very similar structure as the write statement we discussed like two, 3 slides back. So write.format, define the format, define the mode. I want to merge it. Then I want to get it partitioned. So I'm defining the job ID, and then I want to save it. And then run the SQL command, create the table. If the table already exists, then it's fine. If it does not exist, create the table, add the table name. And if you can always write, okay, so this is also important as to, you should always take care of what kind of errors and define what kind of errors I want to see. Because when I am loading or working with terabytes of data, and a job fails after you run it for a day, you don't want that. So that is why Remember, I said fail fast is an option that you can give. And then what kinds of error that you want to see in your log files. Why did the job fail? Was there something wrong in my code? Or was there something wrong in the OS? Or was there something wrong in the type? So you can always define what kind of error you want. I'll pause here for a little bit for some questions. And again, this is a little code heavy, and all of this, like, the more you use, it's kind of, you get used to it. But there are documentations on Spark and Snowflake and Azure, which the links are provided, and you can go and read up and work on this. Okay, so moving on. So now that I explained how to do a batch process, how do you think things will differ if I have a streaming data? Or do you think it will differ if I have a streaming data? What kind of steps do I need to plan initially when I see that, okay, I'm going to load from a streaming data? Will there be change? If yes, what? If there is no change, then that's also fine. No wrong answers.
Like batch data, I think you can time it, like run it every few hours or like once a day. But live streaming, I'm guessing it should be very quick, like probably every second or much quicker.
Yes, that is the time factor, right? But will it change anything in the overall process, the generic structure that I have already defined? Yes, we need to take care of the time, but other than that.
So when you're defining a batch processing, you have you're creating table and doing all those processes, right? But then here you already need to have table like only once, because the data is continuously going into the database, right? So you can't keep doing like you do it in batch processing. So I think it differs, because you have to, in that case, you create table. Here you can create only once and then keep on sending the data real time.
Almost correct. So even in batch process, you don't want to create this whole structure or the table every time. You want to do it once, and once you have defined what your common format is, you want to kind of stick to that. You don't want to change it. So it's very similar to, the streaming is very similar to batch itself. Again, even in streaming process, you have to see if you have any historical data that you want to load. If yes, then you have to partition and load it, because again, it's a day zero load, huge amounts of data. So, and once, you're right, once I have finished off with my historical data load, then it's real-time increment. Now the real time is what you decide. Do you want to refresh it every second? Do you want to refresh it every minute? And then refresh the tables as you go. So you set up a trigger file, like you set up a trigger to run that, let's say, create table or insert to table, it doesn't exist, something like that, a SQL command. And you put a trigger file saying, okay, whenever, refresh it every minute or refresh it every half a minute. So that's something that will be at a much faster pace than, let's say, batch, where you say, okay, I'm going to refresh it every week because I don't really care about refreshes every day and triggering it every day. Does make sense?
Sorry, one question, like this particular program, where does it like trigger? How do you run it? Like, is it scheduled or like?
Yeah, you can schedule it. So that's another, like you'd call it another pipeline. You just write a script and schedule it and say, okay, this is how I want to, every time, let's say I see, I'm just going to pick a random number. Every time I see 50 new data entries, right?
Okay.
Refresh, like run this SQL command. I can just write a code which will be there and it will check if there are 50 files or not. As the moment it hits 50, it will automatically run this thing. So that's the automation process. That is why you want to keep it very generic, very parameterized. You don't want to hard code anything. You want to just make it as much as non-hard code as possible.
Got it. Okay.
So
how
yeah,
about your data filtration? Like, let's say you have so many fields in your data and you just need 2 or 3 fields for the streaming data which is coming in. So how you do that filtration? You don't, your table only may not have, you don't need all the portion of the data coming in, right? Let's say.
So, okay, so is this, so when you say you don't need all the portion, do you mean you don't need to load all the portion, or you don't need it down the line?
Yeah,
work with
let's say as an example, you've shown that tweet, right? You have, there are so many parameters. You don't need
Yep.
all the count. Let's say you don't need the number of counts of retweet, right? So you want to filter it out. You don't want to store in your database, right?
So is that, so that's a good question. So you need to decide it before you build this entire structure. Let's say I have 10 different fields, right? From, let's take the example of the tweet. Number of retweets, right? Where is my function? Yeah, let's say I don't need retweet count. Do I don't need retweet count forever, like ever and ever, I will never need it? Then yes, I can decide that at the get-go. Because once you have decided that format, it's going to stay. So if you have to change that format, then you have to go back, redesign that entire thing to include retweet count. If let's say 2 years down the line, somebody says, oh, I want to see how is the retweet count, and you go back to the database and you see there is no retweet count because we never had it. So then you have to go back and redesign your pipeline to include retweet count. But if you don't need it for an analysis part, then I would still bring it. I would suggest bring it and don't include it in your data science or visualization analysis. But otherwise, it's just like that's what you have to decide, like when you're doing the day zero load. So that's why when you're the design, which even Prachi was saying earlier, in the backend, designing how you would do this is more important than, because writing the code is the easier part. But once you have decided, okay, let's say I want all the 10 columns or all the 50 columns. So that's, again, it's not that I want all the data, right? Because bringing data and running these things also incur a cost. So that's what designing and planning is very much essential for these purposes. I hope that answers your question.
Yes, it is. Thank you.
No problem. Where was I? Yeah. So this is going to be the last slide. And this is, I forget, somebody asked, I forget her name. Somebody asked for the tech stack. But yes, SQL or NoSQL, depending on which databases you're going to use. Python or Scala, as I said. Java sometimes is very important, but if you're going to stick, let's say, to one of the languages from Python, Java, or Scala, SQL or NoSQL, and Spark, because you want it to be distributed computing. So you can use PySpark, you can use Databricks, you can use Kafka, you can use Hadoop, doesn't matter, but some kind of distributed computing. And Cicd, which is very, very important, which is continuous integration and continuous deployment. This is a kind of a diagram which everybody we use, is like you plan, you code, you build, you test, you release, you deploy, then you check the operator, measure, and then again, if something has gone wrong, you plan again, code again, deploy again. So it's kind of in a loop, and it's one step after the other, so that nothing that you have already built breaks, but you are adding to it rather than stopping anybody else's work. So that's all I have for the session. And these are the resources I was mentioning. There's a very nice Spark documentation, Databricks documentation, Snowflake, if you're interested in Snowflake, Azure, Google Cloud, AWS, all have their data engineering courses and certifications. And there is a nice data engineering interview questions on Udacity, which I find very useful. So I'll just leave it out there and I'll take questions.
I see a question from Lisa. Any opinion on favored courses or programs?
On I think courses or by programs you mean computer program like languages or
anything specific you're looking for?
No, I think
I like training, education, and mentioned.
Okay, that
whether
program.
you have any opinions on that.
No, okay, so I'll tell you my experience. I have worked on Azure extensively, and I have done also certification on AWS, and I have also read up on Google Cloud. So it depends on what your project is going to be. Sometimes one is easier versus the other. Sometimes, companies prefer one versus the other. So for cloud, I would say the basic understanding is the same. Sometimes the names are different. If you want to do a certification course, I have found Cloud Academy courses useful. Udacity courses are useful. I think Cloud Academy or Linux Academy, I'm forgetting, one of those. But their documentation, their by itself, Google or AWS or Azure has got its own documentation on certifications. So those are very helpful as well. I know for sure that Azure has a hands-on certification course. Like you can open a notebook and do all the kinds of things. So that is useful as well. For me, I learn more when I do hands-on, so than just reading the documents. Some people just read better. So it's up to you.
Good question. We have another question from Rupali. How was the transition from academia to data scientist role, and what were some of the challenges?
I feel like I'm doing an interview. But I'll start with the challenges. So the major challenge which I faced was I did not have much knowledge about the business side of things. So that's something that I had to learn pretty quickly. So I'm in a consulting company. So we have a lot of clients. So that's something I have not done. Like by clients, I mean business clients. So that's one of the challenges that I had to learn. And being in consulting, you have to learn things very quickly and you have to fail fast. So the time that you get in academia versus in industry is very different. Other than that, actually, I was doing pretty similar work in academia. So I was working on statistical modeling a lot. I was working a lot more on simulations than what I do as a data scientist. So the technical side has, I would say, minimized by a little bit, but the business side has increased a lot more. I did do a lot of presentations to, our grant, like whoever would be coming, but it was different from doing a business presentation. So I would say that was the difference and the time. Like in academia, you have, let's say, 6 months to a year to come up with a solution. Here you have 3 months, sometimes even less, few weeks.
Or even a 2-day proof of
Yeah. yeah, the proof of concepts are really, really crazy. It's like you have to do it in a week, and that is just
2 days to spike and a week to spin up a proof of concept. So that's not short. We have another question.
necessarily a master's.
Do you necessarily masters?
Which field?
Yeah. Are you talking about data scientist or data engineering?
Machine learning engineering? Okay, so I'll just give so for machine learning engineering, I don't know if it is a requirement because I have not interviewed for machine learning engineering, but the machine learning engineers I have worked with, they all have at least a master's degree in some kind of a computer science related course, but I don't know if that is a requirement. So I would just look up at the job description. So yeah.
I have a question.
Sure.
Let's say I'm a backend engineer, not let's say.
Uh-huh.
And I data engineering or data science role. I'm not even talking about my experience. Let's not talk about that. Gives me some leveling up, right?
Sure.
I want to get in the realm of data. Would be a good career path then. This is somewhat career switching, right?
Sure.
What would path be for someone like me who is a software engineer but has a different tech stack or different?
Yeah, I would say software engineer. For a software engineer, a data engineering role is much more easier than a data scientist role. Because as I said, for data scientists, the major thing that you need to know is how to make sense of the problem by building mathematical models. Yes, there are self-study courses that you can take, but in all of these, the main thing that they will tell you is they will also teach you how to do statistics. So if you're not aware of, most of us have done statistics back in high school. After that, not anymore. So statistics or mathematical modeling, statistics and math are pretty much same. Like if you're strong on that, I would say data science or even given your experience as a software engineer, machine learning engineer is something that you can do very, very well. But if you're not if you think that you need to brush up on your statistics and you need some time, but you want to do the switch right now, I would say data engineering would be an easier choice so that it will give you some time to brush your statistics and math up. But if you're great at that, then go ahead.
Yeah. How would you compare the career progression here? Is it like data engineer, machine learning engineer, and then data scientist, or
No,
they go hand in hand?
They go hand in hand. As I said, I work almost every day with a machine learning engineer, and she knows most of the things that I know, maybe not as much as on the statistics side, but importing Python modules, developing the modules, running the code, those are very easy for a machine learning engineer just because they already have that knowledge of how to write the code, how to do the software, how to do the pipeline part. So machine learning engineer and data scientist go very much hand in hand. Data engineering is a little bit different, but again, they are very similar. Like initially, when you're starting your model, you need to understand how your data looks. And for that, you need your data engineer. So initially, when you're starting a project, let's say, you would always need to talk with a data engineer to understand, where is your data coming from? How does this data look? What is the structure? Do I need to do data quality checks? How many data quality checks do I need to do? How are you building the pipeline? Where will my model fit in? So I would say it's like, if you think of the project going from left to right, I would say data engineering comes first. And then there is a kind of a merge between data engineer, data science, data analysts. You all are doing data analysis. And then data scientist builds the model, which is a very, very small part. And then machine learning engineering takes over.
I see. Nice. We have some more questions. I don't know what.
Yeah. Do backend engineers ever use visual? Again, backend is a very broad topic. So yeah, I mean, I can tell you, you can just, let's say if there was no machine learning engineer and you are presenting your proof of concept, right? Like Prachi said, you can't just show that, okay, these are my bunch of Python or R codes, and this is a plot that I have. Nobody is going to understand that except for the other technical person sitting in the room. So if you want to show visualization to somebody who is non-technical, you need to develop visualization skill. It could be on Python itself, it could be on R or R-Shiny, it could be on Tableau, it could be on any dashboard you want. So if you're calling that as backend, yes, then backend engineers do visualizations as well.
Yeah.
But it depends on your definition.
Yeah, I can add to that. As long as you have your data store in place, you can pick any tool that does some kind of visualization for you, right? Like project managers, product owners have their own tools to make sense out of what the data is. They are not engineers, but they need to understand the data and monitor their experiments to see how the new feature progresses, right? Or stuff like that. So visualization, backend engineers can do, PMs can do, data folks can do, depending on what the tool is and what you are actually looking for.
Yeah, what you're actually looking for.
Right.
Yep.
We have a few more questions. How much business acumen does a data scientist need? I find that part daunting.
You would need to know, if you're in industry, I'm guessing you would need to know, because the questions don't come to you as, develop this machine learning model for creating this thing. So there will be a question like, how can I make sense of my customer? And you don't know what that means. So you have to boil it down to what it means in mathematical terms. So you would need to know what, and I will go in detail about all these things in the next part, about how to boil down a business question to a data science problem or a machine learning problem, and what kind of, how you would choose a model versus so on and so forth.
Right. I can add to that. Like, let's say you are in the medical field, right? All your data. It's like you need to understand what that medical data somewhat means to even make sense of the analysis you're modeling, to improve the analysis and modeling, right? Like you would want to know what the data means. Otherwise, if you don't have that specific domain knowledge, you won't be good at what you're doing. Yes, you can use the tools and you can put your queries in, but when you get the results, can you make some holistic sense? And for that, domain knowledge is important. So a lot of these roles require like domain knowledge, prerequisite, or that becomes a part of your job. Like I work at a domain heavy. Like if I don't understand the domain, I cannot even be an engineer. Like I can't even be good at my job. Doesn't matter experience. I have to understand domain is like big chunk of my work.
Absolutely correct. Like I can tell you from a consulting point of view, we jump from project to project, right? Like today I'll be working, let's say, with a healthcare. Tomorrow I'll be working with some communications. Tomorrow I'll work with some media. So it takes me a week to understand the jargons, to understand what they're talking about, to understand what the data means. So yes, math does not change, the models does not change, but how will you interpret that models and tell it to somebody is what your task is. And that is why you are there. And also another thing I would like to add is with all these data engineering, data science and machine learning engineering, is one thing everybody needs to take care of is the privacy and security of the data, because that is utmost important. I know that is not covered most of the time, but that is extremely important. what data is going to be shown even to what end users or business users or stakeholders. Taking care of security and data security and privacy is extremely important.
Yeah, even how you mask and persist your data, all of that.
Yeah. Yeah.
We have a couple more questions from Rupert. Any differentiation between qualitative and quantitative?
I will take that question in the next session because I'll cover that there. So
yeah, does data engineer use user interface tools like Tableau?
To build it? No, they don't use Tableau to, like, they don't build a Tableau dashboard, but they will make sure that the data pipeline that they have built, if a Tableau developer wants to use it, that data is available to the Tableau developer. So they will build that pipeline so that the data is available from the database to the Tableau developer. So they would need to know how the connections are going, where you want the data, so on and so forth.
Correct.
It's a
couple more questions. Is the visualization task part of the data engineering job for end users, stakeholders?
No, the visualization part, it could be done by somebody who is experienced in visualization and who is building the dashboard, or it could be part of a data scientist role. So
yeah,
it depends from company.
Yeah, I can add to that. In our company, we have a very small data engineering team, and they work closely with like stakeholders, project managers, PMs to make sense out of the data, to build new features, to prioritize what features need to be built first. So at least in our company, we have that close interaction between stakeholders and data engineering team. End users are customers, so they don't really care about these things, right? So that doesn't apply. But again, that being said, it differs from company to company, product to product.
Yes, Prachi is absolutely right. It depends. Like, again, like if I am, let's say I am a Tableau developer, I would need to know what kind of data I'm using, and either somebody who knows the data will tell me, or the person who has built the pipeline will tell me. So sometimes there is no Tableau developer, and the data engineer who has built the pipeline has to do the Tableau thing as well. Right. So, it's not going to be as fancy as, an user interface developer building it, but if it does the work, then sure.
For sure. Another question from Cicd. We have another session. We just have 2 sessions in this mini series. The second one is in a couple weeks on Thursday. I'll share the link to that session. We just are doing 2 sessions right now because this is new to the backend engineering group. But do fill the feedback form and give us your ideas. If there is something you want us to cover, then we can totally work on that and provide more sessions on topics that are interesting to you. And Rupal's question, meet in person. I don't think this year, just because we don't want to, let people in and jeopardize. Some of the folks are also who join our backend study group are in East Coast, different time zones. So we don't want to restrict anyone just because we are meeting in person. So at least for this year, this will be online. Thursdays. The good questions. Thank you.
Yeah, good questions. Thank you.
Madhurima and I will hang here for another 10 minutes. If you have any questions, do ask us. I'll just share some resources for all of you. Please provide us your feedback. Join our Slack channel. You can ask questions there, and we'll try our best to answer. And for the next session, if you're joining, come up with questions. I'll just stop the recording.